Alrighty, let's see here. Okay, I don't know if I've fully recovered from yesterday's whole ordeal, travel plus trying to code this hard problem and coming up with nothing. But I have 2 hours to finish this shit. Alright, so I was trying to think of an answer while going to sleep, and I think I should be not using every index in the array, but using the number of elements. So modifying this 3D matrix, it's for every digit. So it's not going to be so it's going to be for dp matrix 0 times, I want to say, n plus 1 or 10. It's going to be 10 digits. So maybe 11. Alright, I think if I were to do the counter on the number of digits, maybe it's actually the number of digits is the number of totals, length of totals. Okay, let's say this n digits is the length of totals. So I think it's going to be n digits plus 1. Okay, so let's go ahead and print out some stuff here. So print the totals. No, this is going to go out of bounds. Shit. Okay, I need to modify more stuff. Number of duplicates of the current value. Dupe count. Okay, I don't think I need duplicate anymore with this. Okay, I think I need to just recreate my whole. I don't remember exactly what the hell I did. Yeah, I don't think I need this dupe count stuff because I'm gonna try something else. Then, other than that, okay. So this stuff is still incorrect. Except for the fact, so the index is in the range of the number of digits plus 1, or it's just the number of digits. Actually, yes. Number of digits plus 1, I think. And maybe I'll just do the print out the DP matrix here. Let's print out using this, and then I'm just going to return 0 right here. Alright, so yeah, there's 2 digits. Length here is 3. Good. I need a non-trivial case here. I think what I used before was 0, 1, 3, 4, 8. Okay, so there's 5 digits, unique digits, and it's 6 length. Okay. Okay, so let's go ahead and create the matrix iterating loop. So for every number of elements, in the range of the total number of elements, which is half n plus 1. I think this is for assuming, no, that's right, it could be odd or even, and that goes up to the bigger of the two, the bigger than the two middle numbers. For the bag sum in range of half plus 1, and for the index in range of the number digits plus 1. Okay, and then the value is equal to, so the digit is the value. So the digit is going to be what is the digit going to be? So I sorted digits. Digits.sort. I want to go from the smallest digit to the largest digit. So if I had total as the counter of digits, I wonder if the counter is always, yeah, because I sorted it, so I think the counter, let me go ahead and just say print out totals and print out, can I do totals at 0? Does that work? I don't think that works. I think it should be, I can't use it. Total 0 gives me, yeah, total counter is a dictionary. So that doesn't necessarily give me the smallest number, it just gives me the frequency of 0, the actual value. So if I want to go through, let me sort the smallest to the largest key within that dictionary, and then, okay, digit vowels is going to be the totals dot key, make that in, I think that's maybe keys. And let's go to this return here. No, this is probably going to still complain about the syntax. Okay, dictionary keys is that. And that is a list, I think. Is that a list? Let's say digit vowels at 0. Yeah, it's not. Alright, I think I need to convert it to a list. Okay, so the smallest number, the smallest digit is 0, index 0, and then if I use -1, then it gets me to the largest. Okay, that's right. Okay, so for every number of E is the number of used elements in your bag, and then for every sum of your bag, and then for every index and the number of digits, and then the digit is the digit vowels of this index. And then then what? We need to know the frequency of this thing. The frequency is equal to the counter, so the totals for this digit. Okay, and that can modify how much I use in the current bag, I think. Yeah. So for every frequency in the range of, I'm gonna ignore, can I ignore zero frequency? No, I can't ignore zero frequency actually. So in the range of digit frequency, in the range of digit frequency plus 1. Okay, so for every possible frequency of the number of times I use this digit in this bag, then the DP matrix for this index, where the index is the digit I'm using, is equal to what? So I calculated, so it's going to be index plus 1, depends on everything to now. Okay. So what was it? Part 1 is DP matrix. Index backs an index. So this is wrong. This is the order of dimensions is E. So let's say part P1. Part 1 is equal to DP matrix using this number of elements, getting up to this bag sum and this index. Okay, what does this mean again? What does it mean again? Maybe I should be starting with actually modeling what the hell I'm doing in this space. Although, actually, this is very similar to it being the same because the number of elements is still 1. Or the frequency of elements is 1. Gosh. Coding is kind of blind in terms of knowing what I expect to happen, or generally I want to have an idea of what my computation should result in. Even the intermediate computation should result in, so I can verify that the code is doing that intermediate computation. But right now I'm just coding it based on feel for what should maybe occur. So part 1 is DP matrix. So I need to incorporate, if I change the frequency at which I add this to the bag. So changing the frequency of adding to the bag is going to change the bag sum and the number of elements that I add to the bag. So I can add 0. So if I add 0, then the number of elements doesn't change, the bag sum doesn't change, but the index does change. So I can say that if I add 0, then dp matrix of the same number of elements, the same bag sum, but index plus 1. Okay, so maybe something like this. dp matrix. If it's adding 0, I know that I can always add 0 and get that. But maybe that should be part of the bigger calculation. So dp matrix, where your elements change the frequency, is changed by the number of frequency. It needs to be capped. It needs to be less than, okay. Say new E is going to be E plus the frequency. New sum is going to be the current bag sum plus the digit times the digit frequency. And the new index is an index plus 1. So if the new E is less than the total E, the total number of elements that I'm using, so less than or equal to half n, and the new sum is less than or equal to h, then I care about calculating this. dp matrix E, new number of elements, new bag sum, and index plus 1. Okay. What does this equal? So it's going to equal the number of ways that I incorporate some number of this digit into the previous stuff. So some number of digits into the previous stuff, where the previous stuff has E values and has E values and I'm adding on to it some number of duplicates. So I think it's going to be, let's say old count is dp matrix of E bag sum index. Is it up to here? I think it's index. And then it's going to be the old count. And so let's say you have, for example, the old count gives you, let's say the elements are 0, 1, 2, 2, 3, and you're adding 5 fours. So your digits, the digit values are 0, 1, 2, 3, 4. Like digit frequencies are, there's 1, 0, 1, 1, 2 2s, 1, 3, 5 4s. And So you've gotten up to maybe the last one, and you're adding the number of ways to incorporate fours into your bag. And the fours would be so if you're incorporating, like, let's say 2 fours, and your previous values were some combination of 0, 1, 1, 2, 2, 3. So you're incorporating 2 fours into this. So for every, so the fours, I think is the number of elements plus 1 is the number of spots that you can choose to put the fours in. And you're choosing number of elements plus 1 is the number of spots you put the fours in. I don't know if that's true. I don't know if that's true. So you have some number of ways of getting up to this point with a certain number of elements. So I think it might be you get your new total number of elements and you're choosing some number of them. You get your new number of elements and you're choosing some number 1 for your fours. So if you previously had 4 elements, no 5 elements, and you're adding 2 more, and it's like 5 choose, it's going to be 7 choose 2. 7 choose 2. Or if you have 1 element and you add 2 fours, then it'd be 3 choose 2. So you're adding these 3 ways. If you have 2 elements, then it'd be 4 choose 2. Yeah. So it's the number of previous ways times n choose r, where n is the new count of elements and r is the number of values that you're adding. Maybe. So old count times math combinations of the new count, which is the new e, choose frequency. Okay. DP matrix. Okay, I think this is. I think that might be right. So what happens for the case of frequency is 0? Frequency of 0, the new e is going to be the same. The new sum is going to be the same. Oh boy, and this is going to be something choose 0, which is always 1. So multiplying by 1, so old count is good count. Okay, I think that works even in that case. Alright, maybe let's go ahead and give this a whirl. Print out the DP matrix. Or actually I have a print out stuff right there. Yeah, I think I need just to delete the streak stuff here. I don't think that was working out very well. This is confusing me. Digit mouse. Digit mouse. Okay, what's going on here? List index out of range. For every index, n digits plus 1. So here the number of digits is 3. Shoot, I think it might be just digits for every index. Yeah, it's just number of digits, I think. Maybe? Alright. Hour and a half left. Okay, is this giving me anything? Nope, sir. It's giving me some stuff in the equals 0. So there's 0 elements. I thought this should always be all zeros and some ones. I thought it should be all zeros. So if I have e equals 0, so I have 0 elements. How is there any ones here? Also, this doesn't seem to go backwards like I thought it was going to go before. I thought this was going backwards. Maybe it was supposed to be a. Yeah, this doesn't seem right to me. So when e is 0, the number of elements is 0. If you have your array, there's one way of getting those zeros there, but this is, the sum is 1. This is sum of 0, sum of 1. And for sum of 1, there's no way if you have 0 elements in your thing. Why is it giving me anything there? So, what's going on here? So, let me go ahead and just print out this thing initially. Okay, print initial. Misspelled initial. Okay, missing an indent. That indent does not match. Oh, it was indented correctly. Alright, so it's starting off okay. And then every number of elements. is it doing here? So somehow it's changing E of 0 for the later ones. Digit times digit frequency. But it's keeping it E the same. Let's go ahead and add in if here. If the new E equals 0, whatever I'm doing, and the new sum is not 0, then I'm interested in what the hell's going on here. Print out E at some digit frequency. Okay, so E is 0, back sum is new E is 0. What is the new back sum? So the number of elements is 0 initially. Oh, well, so if the new E is not equal to 0. Oh shit. If the new E is not equal to 0, the new E is not equal to 0, and this new sum is not equal to 0. Okay, so here I'm saying that no, actually, I want to only focus on where the new E is equal to 0. Oops. Does it do anything? It does, it does. So the new E here is 0. The number of elements here is 0. Frequency here is 1. No, what I want here is I want to know what the frequency I'm adding it to. Oh my god, it's digit times the frequency I'm trying to add. Okay. Digit frequency is actually the number of times it occurs overall. Frequency is the number of times I am trying to add it to the bag. Okay. Alright, that's more like it. So it doesn't mess with the equals 0 deal. So it doesn't mess with the equals 0 deal correctly. Now, why does it mess with equals 1 at all? So, with equals 1, with equals 1, is the old count 0? Is that it? So it should be doing true. So it should be doing frequency when the frequency is 1. Let me just remove this printout. I don't need to start anymore either. Okay, so you're dealing with the element is 0 and the bag sum is 0. Then for every index, so for every index, so let's say my digit is 0. It's not a great digit to start off on. But regardless, the digit is 0. The digit frequency could be, it is 1. 0 appears 1 time. So if 0 appears 0 times, that doesn't change anything. If 0 appears 1 time, then the old count is 1. There's one way to get 0. The new e should be 1. The bag sum should be still 0. And then the new e, which is 1, is less than half n. And the new sum, which is 0, is h. So it should be doing 1 times 1 choose 0, or 1 choose 1. So 1 times 1 should be 1. DP matrix at 1, 0, 1 should be 1. Okay, let me go ahead and wish I could, what can I do here? Let's go ahead and let's say new count is equal to old count times math.combinations of new e and frequency I'm adding. And then this is just going to be new count. And let me go ahead and print this shit out. Print out new e, new sum, print the digit I'm dealing with, then new e, new sum, new count. This is probably too much printing out, but whatever. Or it might not be printing out anything. That's out a bunch of things. But the new count is always 0. New count is no, well, it's 1 on the first. What's going on here? New count is 1 for some of them, but then 0 for everything else. Okay. Zero for everything else. Huh. Okay, so what's going on? New count math.combination of new number of elements in the frequency, which should always be 1. So I'm getting old count of 0. 0 times some number is 0. Oh gosh. So 0, 0, 0, 1. New E is, okay, yeah, 0, 1, 0, 1. The digit is 0, the new number of elements is 1, the new sum is still 0, and there should be a new count of 1. So why doesn't that actually propagate? Is this thing being overridden? Being overridden somewhere? Why does this overwrite right here? The new E is 0. It's overwriting it for something. So the digit is 0 again. The new E is 1. So I'm adding another 0. And the new sum is 0, but then the new count is 0 now. Why? Wonder if it's due to the fact that it's using a higher number of elements. So if there's 0 elements, some of those elements should be 0. There should be 0 ways of getting a higher number, a higher sum. So so why is it getting that? It's getting it pretty late too. So let's go ahead and just grant what the E is. I need more labeling here. The digit using the E and new E, new sum, new count. Okay, so E and new E is 0 and 0, 0 and 0, 0 and 1, but then somehow this appears again. But the new sum is still 0, but the new count is not 1. well, I guess this is the only time this occurs. So what was I seeing before? The new sum is 1, the new count is 0, so there's no way that you add it to 1. The new sum is 2, the new sum is 3. Okay, those other ways are actually fine. So if you have digit 0 and you're adding 1 of it, or 0 of it, the new sum is 0, and there's going to be one way of getting that. Digits 1, and you're adding either 0 or 1 of it, the new sum is either going to be 0 or 1, there's one way of doing that. So everything up to here is fine, but the only issue here is this thing doesn't actually appear in the, this doesn't show up. Because if the new e is 1, the new e is 1, and DP matrix at 1 with the sum of 0 should be 1. Index 1 should be 1. Index plus 1. Yeah, but none of the new count is actually showing up. So if it's not showing up, then maybe it's getting overridden. So TP matrix. So let's say the new e is 1, the new sum is 0. Does this appear more than once? Digit is 0. Okay. I think I see. So if I said that there were no ways of getting if I said that there were no ways of getting it before and I'm adding 0 to it, then there's going to be 0 ways. Maybe this should be the maximum of the current value that's there, and the new value that I'm calculating. The maximum of the current value that's there. DP matrix, new e, new sum, x plus 1. Okay, yeah. It's much better in terms of not having all zeros. Okay. So 6. So it's not. I think there should be some 4s here. So it should be. So if I grab 2, if I grab 2 and the sum is 4, it should be 13310440. So I don't think there should be 2 here. 1041 13310440. Okay. So how did I handle this before? Two elements. Where there's 2 elements up to this point. So so what is this doing here? I think it should be the number of ways that you can get there. Some values that were already there probably. So the new count is strictly adding this element. So maybe this should be new count plus what's there before. Yeah, maybe this would be new count plus what's there before. Maybe it shouldn't be max at all. Let's try it. So new count plus current number was missing. Syntax error. I think I fixed the syntax error. Sorry. Yeah, okay, that's not cool. It's not right. There shouldn't be 2 ways and 3 ways of doing this. It might be that I have initialized too much here. Maybe it should just be dp matrix of 0, 0 equals 1. And maybe that's otherwise fine. Zero, zero, zero. Okay. This looks very, very decent. Obviously, this is for the case where it doesn't actually repeat at all, but this at least looks matching my expectations. Yeah, there's 4s here that I was looking for. Okay, so repeated case. So there's 1, 2, and 2 1s. And the number of ways that you can get to sum of 2 with 2 elements is 1. Seems right. Okay. So then what? So this stuff. I wonder if I try just doing this. If it works. Oh baby, it works. For odds, for evens, it's probably not gonna work. And for odds, it's probably gonna crash for bigger, harder ones. These are all kind of trivial. So let's go and just do a harder odd one. So there's 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh baby, say it ain't so. Okay, so now for evens. If it's even, then it should be DP matrix of use all your numbers half your sum and up to last index. I don't think this is right. Squared. This cannot. This is just. There's no way this works. The test case worked. I'll use my other test case that was the classic 0011223344. There's no way this works. Yeah. So I think here the no, it's not squared, right? It's actually times 2. So the number ways of doing, what is it doing here? Getting to the last elements. This is just not correct. Yeah, 90,000 times 2 is not 19,000. And it's not this either. Oh, gotta think of this. So what should this be returning here? Number of ways you can sum to half using all your elements. Is this last square? So the issue is the ways that you sum to half your elements using exclusively 4 elements, like let's say the total number of elements is 9. If you use the sum of like using 4 elements versus 5 elements, this would be using 5 elements, this is using 4 elements out of the 9. Those are all distinct. Those are strictly distinct ways. So when you multiply them, you get a distinct sum, or sum that doesn't overcount. But here, if you have 10 elements, your sum is 20, so half sum is 10. You have 10 elements, and you're saying that there's 300 ways of I'm getting a half sum that adds up to 10. There's 300 ways of doing that. You're looking for the split. You're looking for the split between the number of ways of doing You're looking for the split of that 300, so that you can multiply one part of that split with the other part of that split, rather than multiply. Because so if like this 300 includes, let's say 00244. You can't multiply that 00244 that so some count of that with itself. I guess you can only multiply it with something that is the opposite. I think this boils down to having two frequency measures. One for the smaller and one for the bigger one that I was working on previously. So, for instance, the frequency of the current one, or the count for the current frequency and the count for the other frequency. Interesting. So it matches. How do you tell? Because then you need to keep track of that distinction. I don't even know how you tell. $300 times 300 is 90,000, so that's way too big. It's some split of 300. Some split of that 300 value. How do you get to that 300 value at all? Because you're not. So you're splitting that 300 value into like some smaller frequency set and some smaller count and some bigger count, or some count based on certain frequencies combining versus other frequencies combining. How do you even tell? Let's split this thing up. I wonder, what if you try to make everything odd? If you inserted like another 0. If you insert another 0, how would your answer compare? We'll go ahead and see. It just doesn't work currently, even with another 0. Oh boy. That's unfortunate. So why does the other ones work? Oh boy. Okay, so let's do something simple that maybe can still test. So 1, 2, 2, 3, 3. Okay. It still worked, unfortunately. Say 3 zeros and 2 threes. Probably still works. Fuck. So 3 zeros, 2 ones, 2 twos, 2 threes. Where is this failing? Okay. That failed. So 3 zeros, 2 ones, 2 twos. Okay, so adding the 2 threes, that kind of screwed things up. Huh? Keep on digging, I guess. Or maybe it's just adding 7s? 7 total? No, 9 total. So let's say I had 2 more zeros. Okay. 2 more zeros doesn't break it. So let's say 4 zeros and 3 twos. 4, 8, 7, this is 11. Okay. Yeah, it does seem like my streak is going to end here. Unfortunate. So 4 zeros. 2 ones, 2 twos, 2 threes. Or 2 ones, 2 threes. 3 twos, 2 threes. So this thing seems alright on the first level. And then it seems alright. I wonder if I can get a streak saver. Leetcode. Streak saver. Some coins. Leetcode coins to me pause this to look at something. Okay, I guess there's something called time travel tickets that I can use to restore a streak that I can't solve within the day that's being assigned. Oh my god. Okay. Luckily I can probably use that for this thing then. Still doesn't help me solve this thing though. Maybe removes the stress of urgency. Okay, so what's going on here? Why is this giving such a big answer? There's 4 zeros, 2 ones, 2 threes, 3 twos. Let's sort. Counter. You know what? I mean, it's weird. Like, I wonder. I wonder if it makes any difference if I do totals, not keys, sorted. I am thinking about these in terms of increasing values. Nope, not at all. Why is this thing messing up here? So this is 4, 2, 2, 3. So it's an odd number. So there's 11 elements. So half of that is 6. So it's 0 to 6. Where is this messing up? So it's 6 times 5. So I'm doing 360 times 140. And getting 50,000. 300 times 100 is 30. 300 times 100 is 30,000. Okay, yeah. That's way too big. So there's maybe some duplication in what I'm doing. The number of ways that, so where is this messing up? Why isn't it messing up for something smaller? Say 0, 3, 4 zeros, 3 twos. Man, I wish this could mess up on something smaller so I know I have a better chance of modeling it. Okay, let's add more twos. 4 zeros, 5 twos, 7 twos. Okay, 4 zeros, 7 twos, and a couple ones. Okay, let's simplify it now. 4 zeros, let's say 2 less twos. Alright, let's say 2 less twos again. Okay, let's say 1, 2. Okay, excellent. Let's say 2 less zeros. Excellent. Right. Let's see. There's this. I should be able to figure this one out. Small enough sample size. So 2 zeros, 2 ones, and a 2. So that's fine. Sum here is going to be 4. So half sum is going to be 2. So half sum should be 2. So the number of ways of getting with one element the sum of 0 should be up to the first digit. Should be 0 here, and then 1 if you could just add a single 0. And if you use 2 elements, then there should also be 1. Although, well, this is a little weird. I think it should be, yeah, yeah. So I'm thinking digits here. Okay. So using my 0 digits, and I'm picking 2 of them. There's one way. Yeah. Okay, and then the sum is 1 using digits that are 0 and 1. I get 1. Okay, that's fine. And here the sum in here is 1. And I'm using 2 digits up to 0 and 1. So it could be 0, 1, or 1, 0, so there's 2 ways. This seems off, maybe? No, the sum here is plus the 1, okay. And the sum here is 2. Sum here is 2 up to the digits 0s and 1s. This is a 1 and a 1, so that's one way. And up to here it's 0, 1, 2, 0, or 0, 2, 2, 0, 1, 1, so there's 3 ways. It's fine. Using 3 elements, there's no ways of getting 0 because you can't not have zeros. Using 3 elements, and those elements are 0s and 1s. And this is wrong. Using 3 elements, there's no way of getting. No, here the sum is 1. The sum is 1. So it's 0, 0, 1, 0, 1, 0, 1, 0, 0. So there's 3 ways. The sum is 1 using digits 0, 1, and 2. Same. Okay. And then the sum is 3 using. And the sum here's no. Sum here's 2 using 3 elements. There's no way of doing that with just zeros. No way of doing that with just zeros. No, there's a way of doing that with zeros and ones. It would be 0, 1, 1, 1, 0, 1, or 1, 0, this. And then for summing a 2 with 3 elements, summing a 2 with 3 elements, be 0, 0, 2, 0, 2, 0, 2, 0, 0, or 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, so let's say E3 sum is 2. So 1, 1, 0, 0, 1, 0, 0, 1, 2, 0, 0, 0, 2, 0, 0, 0, 2. and then E is 2, sum is 2. That's 0, 0, 1, 1, 0, 1, and 0, 1, 1, 2, 2, 2, 0, 0, 2. So I'm multiplying 3 times 6. I'm multiplying 3 times 6. And I'm getting 18. Oh, interesting. Because they're not disjoint. Oh my god. How are all the previous ones freaking disjoint? So here I'm using some number of 1s, 2s, and 0s, but if I use, yeah, so if I use a 2 here, I use a 2 here, they can't multiply. Like not all the ways of doing this matches with the way of doing this to do a split. Alright, well, I have to figure out this issue at some point, even if it was odd or even. Probably simpler with the odd case, to be honest. So how do I match the count of the ways of doing one with the ways of doing the other one? Interesting. Count of the number of ways of doing one. The count of the number of ways of doing the other one. In theory, it should be like, well, it should be 1, 1, 0. So these ones, these three match with these two, and that gives me 6. And then these three match with this single one, which gives me another 3. That adds to 9. I wonder, maybe I need to do so the issue is also the fact that each of these counts is a single number, and the number of ways that I get to the number of ways that I get to this 6, I don't keep track of the frequencies involved. So even if I could, on the second to last kind of increase of this to 6, I don't know what the previously used frequencies were. So like I can list it out here, but I don't know, or I don't think I know how I got to here. It's just like this is just 6. Like it's not, the information is not readily available to split up into this this particular arrangement of this particular permutation of digits. These permutations of digits. Just know this is 6 and this is 3. Huh. Unless I actually include more information. That'd be a lot of information because the numbers are so big. Also, I forgot to include mod and all this stuff. So maybe this should be return. Some of this stuff should be modded. Yeah, should be here. %mod. And this should be maybe mod. Of course. So how to go about this? 0, 3. Three times 6 is 18. But so did I track the frequencies? But would that take it too much space? So for each element, it's not like a single number, but it's like a list. Or a list is different ways of getting there. By which I mean like a certain frequency of summations. Certain frequency of summations. So I think that'd probably be too much information. Maybe just too many paths. Like even the biggest numbers in the list. The list would be tuples that are 10 size for the frequency of the number of digits for each combination, and then there'd also be a bunch of combinations, like so many combinations. Combinations. Here's 6. This boils down to two tuples in this spot. So this would have 2 tuples there. This would have 2 tuples. And then, in theory, you could even get away with maybe for odds going just to this thing. Because for odds, if you know the tuples that get to here, you can calculate the complement frequency, you get the other tuples that would combine to this thing, and then multiply those out. But then would you know how many things? You would know the frequencies. If you know the frequency, then you can calculate the number of ways. If you know the frequency, then you can calculate the ways. Actually, yeah, maybe the number of ways is what I'm storing currently, but maybe I should just be caring about the frequencies. Because I can always reverse engineer the number of ways based on the frequencies like I did before. Like, given some frequency, I can determine yeah. Given some frequency, I can determine the count of the number of waves. So if I'm storing frequencies, then what? So I'm adding on to each spot a list of things. I'm adding on to each spot a list of other frequency tuples. And then at the end of the list of frequency tuples. And then the list of the size of the tuples is going to be the number of elements. Not quite. It's at most the number of elements. Each element's unique, but it could be less. No, it's the size of the frequency tuples has to be exactly the number of unique digits that I have, since I need to know the count of each unique digit. It's a pretty big change, but I think I don't see another way of breaking this number down into more information without it. Okay. It is what it is. So DP matrix of 0, 0, 0. Instead of storing 1 as the number of ways of doing that, it's going to be 0. It's a tuple. Fuck me. Okay, I need to store this as a list. So this is going to be a list. So the issue here is, if this is a list, then every single way of getting there is going to be modified to get the new list. Every single element in the list would grow. Well, any later list would be the pending of the previous list with some modification. That doesn't seem correct. No, right? There's no. Doesn't seem that right. I don't know if I want to do that. Although I don't know if I can come up with another way besides that. So each element there at the example. Okay, so the number of elements is 2 or 3 out of the 5 elements in the array. And I want to say that there is one way of getting the sum of 2 with 2 numbers, and that one way has 3 other ways of getting, and there's 2 ways of using 0 and 2, and the number of ways of doing the other numbers is 3. So 2 times 3. 2 times 3 is 6. It is in fact 6. Okay, so let's consider this. So my numbers are 0, 0, 1, 1, 2. E is 0. E is 1. And E is 2. And E is 3 perhaps. So let's say my sums are going to be 2, 1, and 0. Sum of 2, 1, and 0. So this is 2, 1, and 0. Alright, show, and my values for my digits are going to be 0, 1, and 2. And 0, 1, 2. Okay, so if I store tuples, so this tuple would be like 0, 0, 0. This tuple would be 0, 0, 0. This tuple would be 0, 0, 0. So if I have all zeros, I'm using 0 elements, so there's like one tuple in there. There's nothing here. There's no valid tuples. And then I do 1, 1, 0. Actually, I mean the tuple, yeah. So the tuple would be using 1, 0, 1, 0, and nothing else. And the tuple here would be, actually the tuple here is using 0, 0s, right? No, it has to use 1, 0. 1, 0, 1, 0. So this is the number of zeros I'm using, the number of ones I'm using, and the number of twos I'm using. And up to this point, I can only use the digit 0. So obviously these other ones are going to be 0 in the tuples. And there's no way of summing up to 1 or summing up to 2. And then here, using two elements, the sum of which is 2. So there's one way of doing that. If I use 2 zeros. No. Tuples represent the frequency of the numbers I'm using, so this is actually 2. It's not the count. Each tuple represents some implied count, but the tuples themselves contain the frequencies. So up to the digit 2, this is that still. Using 2 zeros. And then if the sum is 1, there's no way of doing this. And there's actually, if I use 1, 0, and 1, 1, that's one tuple. And this one is actually, there's two tuples. There's, actually it's 1, 1, 0, and that's it actually, 1, 1, 0. And if the sum is 2, then there's going to be like 0, 2, 0, using 2 ones. And this one is 0, 2, 0, or 0, 0, 0, 0, 1, using 1, 2, with, using 1, 2, and 1, 0. Oh, I'm screwing these ones up then. Using one element and summing up to 1. There's no way of doing this. But there is a way of doing this, and it's going to be 0, 1, 0. This is still 0, 1, 0. There's no way of getting to 2 with just one element. If I have a 2 here, and then with 3, and then with 3. I don't think there's any ways of doing this. Or this, or this. And summing to 1 using 3 elements. So it could be 2 zeros, 1, 1. No, but I'm only using zeros at this point, so there's no way. And then if I used both zeros and ones, and 2, 0, 1, 1, and if I use everything up to 2, so it'd be 2 zeros, 1, 1. And then sum up to 2. no ways of just using zeros to sum up to 2. There is a way with getting this thing using 2. Now using 1, 0, 2 ones. And then here using 2 zeros and 2, or what's it? 2 zeros, no, 2 zeros and a 2, or 1, 0, 2 ones. Okay. Okay, so these are the tuples 2, 0, 1. That match. There's 2 ways of doing this. No, 3 ways of doing this. 2, 0, 1. No, 2 zeros and a 2. There's 3 ways of doing that. And then that matches with this 2 ones and 2 ones, which is 1 way of doing that. 3 ways of doing that. So that matches. And this tuple 1, 1, and 2, 2. 1, 1, 0, and 2 ones. That tuple, 3 ways of doing that, matches with this 1, 0, and 1, 2. There's 2 ways of doing that. So 2 times 3 is 6. So what? What does it show me? I can graph this. I can chart it on something basic like this. Like these strings, this chain is going to be longer and longer as there are more digits and there are more combinations to get to that sum. And these chains are going to get longer and longer. In theory, the initial ones are only, the tuple size should only be up to the index size, or the particular unique digits. So in theory, it's like if you go up to 0 digit, then there's only one value that you would care about, because the other values can be zeros. So in that sense, you can probably eliminate some information. The tuple could be smaller, and your average tuple is going to be just n divided by 2, or the number of digits divided by 2. Even there. But then with each tuple that you have, adding on to it, the number of tuples can grow by n squared. Like if you were to do this thing, this is just for equals, the sum is 2, but if you were to go up to like sum is 9 or 10 or 11, grows by maybe the factorial. Not even polynomial, but factorial. There's just so many. Well, is there? Like the ones that I was working on, 2 zeros, 2 ones, 2 twos, 2 threes, so it's like 300. Then of those 300, how many tuples were there actually? Those 300s, how many tuples were there actually? Alright, well, don't think I'm going to make this before the streak runs out. And then I have to purchase the streak extender, streak time travel extension thing from the store. So I'm going to give this a fail, and then maybe do this another time.